Welcome to surveying class. So today we are discussing unit 4, measurement of vertical distances, and this is the last lecture in this unit, that is the error and mistakes and the precautions in labeling. So in this course, in this unit, basically what we have discussed as of now is using the dumpy level or auto level or maybe a total station. We can measure the vertical distances, we can measure the elevations of different points. So for example, this is maybe the ground terrain. So using this dumpy level instrument, we can find out what is the terrain here, what is the height here, what is the height here. So height of each point can be determined. So in the previous lecture we have seen in details and the different techniques, different types, how to measure all these things we have seen in details. So this is the last lecture where we'll be discussing about the errors, mistakes and the precautions. So we have seen in the earlier units also that the errors or the mistakes will be always occurring in the measurement. So whenever we take any measurement inside, there will be many possibilities that error will be introduced in our readings. So some errors may be unavoidable, means because of many reasons it can definitely come into our picture, come into our measurement, whereas some errors are actually mistakes, means mistakes of the surveyor or maybe mistakes of the assistant, or the mistakes of the office engineer, this error introduces in the reading. And also what are the precautions we have to take it, that we'll be discussing in this lecture number. So let's get started. So the first error which will be coming into our reading, that is the instrumental error, and which is very vital. So error in the permanent adjustment, we have seen in the earlier lectures also in this unit that at the beginning itself that we have to set up the instrument correctly. First we have to do the temporary settings, and then we have to do the permanent settings also in the readings, in the dumpy level or maybe auto level. So if any error made during this permanent adjustment, then this will add error into our calculations. Right. So for the major work, basically instrument needs to be tested and if required, right, and get to be adjusted. So if you do any precise works such as maybe laying up of the railway tracks, because see the railway tracks, the elevation will very much vital. So if you make any errors in the elevation calculation while laying out the railway tracks, then it will produce the extra energy, and also it concerns safety. It will have a safety concern in the railways also. Whereas if you are doing a highway survey, like a highway road will be constructing in the line, and there you are doing the surveying. So in that case, basically the accuracy may not be that much important, because if there is any small error, means the if evaluation or if the elevation in the road is small change is there or small error is there, then there is not much consequences because of this error. So depending on what type of survey you are doing, this instrumental error is very much vital. Now the next type of error which will be introduced is defective stuff, right? Like whatever we have seen, right, we are using a label instrument and also the stuff. In the stuff, basically the graduated readings will be there, and there basically through this instrument, label instrument, we check what is the line of sight point, and accordingly we take the measurement. So if there is a possibility that the stuff which are we using, that also may be defective, so in that case the error will be introduced. So sometimes what happens in a staff, basically if this is a staff, and then so much marks will be there, right? 1 meter, 2 meter, 3 meter, up to 4 meter stuff we have. So these are the marks which will be there in the stuff. And sometimes these values are not standard, means the distance from one mark to another mark is not perfectly calibrated. So in that case, that also will be an additional error which will be introduced in the reading. Next one is error due to the defective level tube. So we have seen different level tubes are present in the dumpy level as well as auto level. So these level tubes are helping us to set the instrument, permanent instrument and the permanent adjustment and the temporary adjustment also we are doing using this level tubes. So if there is any error in the level tube, means the although the instrument is not horizontal but the bubble is at the center, this will be defective level tube. And if you have a defective level tube, then again the line of sight won't be exactly horizontal, and which will produce again the errors. So the bubble of the level tube may remain central even though the bubble exists, axis is not horizontal due to the some reason, right? So this will basically introduce the error in the reading. Now the next type of error is error due to the defective tripod, right? So all the instruments which we have used in the in the surveying, so those instruments will have, if any instrument has any error, so this will produce a, error in the measurement also. So the last step you have seen is the error is the defective tripod. So we are using a tripod, right, where the level instrument is mounted. So if there is error in the tripod, means tripod screws are not tight, so in that case you already made the permanent adjustment, but because of some reason the instrument balance got disturbed, so in that case again you have to do the permanent setting once again. So this will introduce the error due to the defective tripod. So what we understood here is no instrument error. So first one is the instrument, because of the dumpy level or the level instrument itself, the error is occurring in our measurement. So this is the first one. Second one is if you have the defective stuff, so the stuff, if it is not standard, then again it will introduce the error. Third one is error due to the defective level tube. So level tube we have used, right, for the leveling purpose, for permanent setting and temporary setting for our instrument. So if that has an error, so this will introduce the error. And the last one we discussed about the error in the tripod. So the tripod the dumpy level is mounted on a tripod, so this also will additionally mm, uh, introduce the problems in our readings. So now the next type of error we have discussed is the personal error. So personal error will occur, because of the surveyor as well as the assistant who is assisting for the surveying. So the perfect, personal error due to the imperfection and the temporary adjustment of the instrument, right? We normally do the temporary adjustment. After that, we do the permanent adjustment, right? So if there is an imperfection, so basically skilled surveyor is required to set the instrument at site, because inside ground may not be flat, so there may be undulation in the ground, or maybe the surface may not be smooth, so in that case also the error will introduce. So that's why the skilled surveyor is very much required for the permanent adjustment, the temporary adjustment of instruments also. So next is basically carelessness setup of the instruments. This is again very much important. So instrument has to be properly mounted, and also the properly set up on the ground itself, because if there is any small disturbance also nearby, for example, you have set up an instrument tripod basically, and then you made the temporary permanent adjustment, both the adjustments is done, instrument is now perfect, but still if a heavy vehicle is passing by, then what will happen? Because of this ground shaking, the again instrument setup got disturbed. So in that case, again we'll get errors in the reading. So what we have to do is we have to make sure that instrument is actually kept on a ground firmly, so that even the small vibration is happening, the instrument setup should not be defected, it should not be hampered. So that is the carelessness setup. This is this part. The next one is the imperfect leveling of the instrument, right? So sometimes that using this bubble basically we do the leveling of instrument, right? If instrument is not perfect, that we have seen in the last slide, and also the bubble is not centered, right, and you started the leveling, you started taking the measurement, so this will introduce the errors. So these errors, all errors, if you see, these errors are introduced because of personal error. Now the next one is imperfect focusing. So we have to focus, right, two lenses. One is this eyesight, and another one is the object lens, right? Two lenses has to be focused perfectly. If it is not done, then again the readings won't be clear to the observer, and also this will introduce the errors in the reading. Next one is error in sighting. So we already have a cross here, right? We have seen in the earlier classes also. Basically, you have the this telescope, and in the center you have this cross here. So in the diaphragm you have this crossword, so the object which we are sighting, so this object should be at the center of this diaphragm, right? If that is not done, error in sighting may occur, so that also will introduce the additional errors in the reading. Next one is error due to the staff not held vertically. So the staff which is one assistant is holding at the another part of the level instrument, so if that is not holded vertically, so if the instrument, maybe if the staff is not vertical, it is inclined, then what will happen? So this is the ground surface and staff is not vertical, then what will happen? So you will line of sight will be coming here, so basically the length will increase, is not it? so the length will increase. So how to resolve this, whether the instrument is vertical or not? So what we have to do, so one person will be standing right with the instrument here one end, so this is tripod and instrument is mounted here, and another person is holding the staff. So if the staff maybe he is holding is not straight but it is inclined, then whatever reading he takes here, so this reading will be longer, right, because it is not straight one. So this is the actual reading, vertical one, but he has taken the inclined reading. So in that case the reading will be increased, right? So what he has to do is the surveyor will give some signal, so that he will now move. Initially it will be in this position, then surveyor will give a hint, so that he will now change it. So now he will rotate it to that forward and the backward. So he will take multiple readings, the surveyor will take multiple sighting and multiple reading, and which one will be the least one. So the initially if it is inclined, then this length may be a 3 meter. He got it, surveyor got it 3 meter. Now he asked the assistant to move this forward. So whenever he makes the forward, then the reading got reduced and it is now 2.5 meter, for example. Although in reality it may not reduce that much, but although I'm giving an example, because initially it is in inclined position, so the reading was 3 meter, now it is vertical, so it will be 2 meter, right? So like that, surveyor will be giving a signal, so that he will change the alignment of this stuff, and which one we got the minimum reading, that will be the actual reading. So like that basically we can reduce the errors in the stuff. And next one is the error in recording. So recording means what? So he is a surveyor, right? So he will be telling, okay, what is the reading, maybe 2.5 meter here. So loudly he will say, is not it? So one more person may be there, he will be recording whatever he said. So that is basically errors in recording. Or sometimes we have the backside foresight column. So we have seen in the last lecture also that while recording we have multiple columns. One will be backside, one will be intermediate side, another will be foresight. So sometimes surveyor, instead of writing backside, he may write it in the foresight, or maybe instead of intermediate readings, someone can write in the foresight. So this also will introduce error, right, in the ultimate decisions. That is basically error in recording. Now the last part is basically error in computing. Error in computing means what? So sometimes what happens, this calculation we have done it, right, using the rise and fall method, and also using the height of instrument method. So while doing this calculation, there may be a small mistake in the subtraction or the addition of two readings, there may be error. So that error is because of this error in computation. So now you have seen basically there are two types of error which can introduce in the in the reading. First one is the instrument error. Again, in the instrument error we have seen each instrument can produce different values for the mm, measurement. And next one we have seen is the personal error. So what are the different causes, the reasons for adding the personal errors in the measurement. So now error due to the natural cause. So first one is actually error due to instrument, right? So if you correct the instrument, then the error will be more corrected. Now next one is the personal error we have discussed in the last slide. That is, if the recordings, or if the instrument, if the person, if the surveyor is a very skilled surveyor, then this personal error will be very much less. So that also can be reduced. Now the third one is error due to the natural cause. How? That is, there are basically two ways error can introduce in the environmental cause. So first one is the curvature of earth. If you see, so this is our earth is not exactly flat, right? Our earth will be spherical in nature. So this is our earth structure. But wherever surveying we are taking, that is through this telescope we are looking, right? So we are using these properties of light, and we are taking the measurements. So whatever we are taking measurement, that will be the horizontal measurement we are taking. But if the distance is very far, for example, one point is x and the point is here, maybe y, the x to y distance may be 100 kilometers, or maybe 50-60 kilometers. So in that case, the earth curvature also has to be considered, that we have seen in the earlier lectures also. So the actual line of sight is this one. You can see this is exactly horizontal actual line of sight, whereas the earth is actually curvy, right? The surface is not curvy, it is not horizontal. This is actual level line, is not it? So actual level line, let me draw it here. So maybe actual level line will be something like that, is not it? Actual level line also spherical. So that is basically the errors. So whenever you look at, you will see this point, right? XH is the reading you will see. from the L dash, if you look, you will see x dash xh is the reading on a stuff, whereas because of this level line, the actual height will be xl, right? This is the blue line is the level line, whereas from the telescope you have seen is the xh. So the error is basically this one, e total error is basically, this one, from xl to xh. So this is the total error. So this is the first type of error which we have discussed, is the error because of the earth's curvature. And the next type of error which will be occurring is the refraction of light. So as we are using the properties of light, light also gets refracted, right? Because if there is any change in medium, like if light is traveling from one medium to another medium, there will be refractions in the light. So because of this reflection also, the additional error will be added into our reading. So how? So this is the line, actual line of sight, is not it? So this deep blue or the violet color is basically the actual line of sight. Whereas, because of refraction means maybe because as the points are very far apart, so there may be change in the density of air here and here. Because of this, the light is not going straight, but this pink color line you can see, so light got refracted. And this is the readings, er is the reading because of the refraction. So you have seen now the total, earlier the error due to curvature of earth was xh to xl. So the entire distance was the curve, was the error, but and this portion is the error, because of refraction. I understand. So now the total error will be how much? So total error is this much, right? Total error will be this much, xl to xa. So this portion is the total error. So let's compute what is the error due to the natural cause. So now we understand error due to natural cause. There are two types of errors which is introduced. First one is the curvature of earth. So curvature of earth has to be considered, and second one is the refraction. So EC is basically the curvature due, error due to curvature, EC total distance, whereas ER is the error due to refraction of light. So now let's compute what is the error, what is the exact value. So error, you understand now, is total. Let me go to next slide and it will be clear to you. So the total error, you understand, is this one. Right now if you take a rectangle here, so this rectangle I was talking about, okay, so in this rectangle basically, let me write it here. So this is O H and this one is P, right? So what, no, not this one, let me correct it. So if you consider, so this is the art surface, right? Art center maybe here, and if you take this type of triangle, so this is your O, isn't it? So there is a triangle here, O, P, and H, right? And now from this entire triangle, basically this brick triangle, so this is the radius of earth. So this portion is the radius of earth, this is also the radius of earth, is not it? So this is a rectangular, this is a triangle basically, and from there oh square, oh means what? This one is oh square, with this angle is 90 degree, then oh square equal to op square plus ph square, right? Is not it? This is simple triangles, Pythagoras equation we have written. So now what is OH? So OH, from here to here we are talking. So OH will be ready. Let me write it. So from this point to this point is what? Radius of Earth, is not it? Radius of Earth, we call it RM. So this is also radius of Earth. So this portion also RM. Right, from this point to this point is the radius of Earth. So this entire O to H will be radius of Earth plus the error EC, is not it? So radius of earth plus error EC square is equal to OP is what OP is this one. So this is again RM square, right? Radius of earth square plus PH square. PH is the vertical distance, horizontal distance between the 2 points. One is the instrument as well as next point is the where we are taking the observation. So from this expression easily we can compute what is the EC value. So EC value is this one, right? So now here if you see we have removed the EC term, because EC with error is very much less compared to the radius of earth, is not it? Radius of earth will be 6000 kilometer, 6300 kilometer radius of earth, whereas the error EC will be hardly 1 meter maximum. So this portion is very less compared to this one. That's why EC can be ignored easily, and pH square by 2 RM is the final expression. This is the error due to the curvature of earth, EC. And if you substitute the value of the radius of earth, which is 6370 or something you can put, and this will be the simplified expression for that. So this is EC is the error because of curvature this is introduced. So next one which I have discussed is the error due to the refraction. So error due to the refraction will be, this is the figure you can see. This is an enlarged figure which I have drawn in the last slide also. So error due to the refraction will be what happens. See, now the original actual level is this one, right? PL. So Earth is a curve, is not it? Same spherical in nature. So this is the original level line is PL, whereas the light and the actual line of sight is actually PA, which is not exactly horizontal. Because of refraction, light got refracted and it went down. Now the staff reading is basically reduced, is not it? So this is refraction ER. So that's how actually refraction, error due to refraction is occurring. Now if you combine both error due to refraction and error due to curvature, then this will be the final expression you can consider. So ECOM, with combination of both the errors, is basically 0.675 d square in meter. So d is basically horizontal distance between those 2 points. Okay, so we can use this expression and and for calculating the error. So you can, what is the vertical horizontal distance between the 2 points you are measuring, either it will be 50 kilometer or 100 kilometer between the 2 points, and based on that basically you can provide the value, and that will give you what is the actual error because of this natural cause, ecom. Okay, so now this, apart from those errors, we have now other errors also. The next error is error due to the wind, right? If a heavy wind is blowing in that region and you are measuring the distance, this will basically shake the instrument from the original position. Also, the person who is holding the stuff, it is very difficult for him also to hold the stuff in the wind's condition. So that also introduces the errors in the breeding. So that is error due to the wind. So thus it is advisable to suspend the work in this condition. Next one is due to the sun. So due to sun, basically the stuff which one person will be holding, the assistant will be holding, because of this central sunlight, basically the stuff reading may not be clear. So that also will introduce the error. So that's why the reading has to be taken in a shadow condition, whereas proper line of sight and also a full visibility is there. Next one is error due to the temperature. So as we have seen in the earlier slides also, that because of temperature, maybe the light also get refracted, is not it? And also the because of the temperature is very high, in that case the stuff is also made up of steels, right? So the length of the steel also may increase. So this error will introduce because of the temperature rise and or fall. Okay, so that also has to be considered while taking the measurements. Now you understand what are the total errors coming into our labeling instrument. So now the next one is the mistakes in labeling. So what are the mistakes? So basically this type of 4 types of mistakes can be occurred in our reading. So first one is the mistakes in reading. Means the person will be reading, I mean those the surveyor will be looking the stuff through this telescope, right? So there may be a possibility that error will be introduced. So that is a mistake in reading. Like in the stuff, basically multiple readings will be there, right? So that is the stuff, and this type of readings will be there, and he have to read. So one, maybe 1.1, something will be there in the stuff. So while reading those values, there may be error. So that is a mistake or blunder, basically we call it, because this type of mistakes are basically simply unskilled surveyors will do this type of mistakes. Next one is mistakes in recording. So once the surveyor will tell, okay, this is 4.25 reading, so immediately one more person will be there who will be recording this reading. So maybe he will write maybe 4.3, or maybe he put this value into some other column, not in the appropriate column. Then again the error will be introduced. Next one is mistakes in computation. Already we have discussed, right? So the addition, subtraction, we have to do it in the table using the right and rise and fall method, or maybe height of instrument method. So there also may be mistakes. And the third one and the fourth one is improper holding of stuff. So now the mistakes in reading, what are the mistakes can be done, that already we have discussed. So the reading the stuff is in wrong direction, means the stuff is maybe what happens, let me draw it here. So what happens is in a stuff, basically you have 0, 1, 2, 3, like that it goes, right, from ground side. So if someone is holding the stuff in opposite direction, right, that is upside down, so in that case again this will introduce the error, right? So that is the first point which we are discussing. Reading the standia here instead of center horizontal layer. So as we have discussed, in the telescope you have this type of cross here, right? So if the whatever by this point you look, that reading has to be considered. But sometimes someone will take this reading or this reading, this will introduce errors in the reading. Next one is reading the wrong figure in meter or in decimal point. For example, you already surveyed the original point is 1.250, but what he's recorded is 1.025. So this is like this type of errors may occur also. That's why we have to make sure that readings are correct, right? Next one is mistakes in recording. As I said, that we have to enter all these values into the field book, right? Field level book. So in that case, some values may be interchanged, or maybe like 2.425 some surveyor said, but while recording it is written 2.245. So this type of errors also will introduce in the recording. Now the next one is the mistakes in computation. As already I have discussed it, the backside forward addition subtraction has to be done. So that also computation error we are required. So always it is better to check, arithmetic check has to be performed using this rise and fall method we have discussed, right, in the last lecture also, how to do the arithmetic checks whether our readings are perfect or how much error is introduced. We can check it using this method. And the fourth mistake is basically improper holding. That also I have explained. For example, if someone is holding the stuff in an inclined manner, then the reading will be increased. So how that will be rectified? So the surveyor will tell that to move the stuff, bring backward and forward. So whichever you will get the minimum reading, that is in that case the stuff was exactly at the vertical. So surveyor will simply take different readings by different alignments, and which one will give you the least value, that is the correct reading. So now you understand what are the errors and how errors are introduced into our measurements. Now what are the precautions we can take to mitigate those type of errors? So the following precautions can be taken. The stuff should be held vertical. So whatever stuff will be there, that should be vertical, is not it? Next one we have to check is the bubble in the label tube is brought at the center. So the bubble will be there in the label tube, that should be coming at center, right, before and after taking the readings, that we have to make sure. Third one is the reading should be taken in proper direction depending on the type of stuff, right, upside down and downside up, that has to be considered, and the reading has to be taken. So balancing of sight is to be maintained as far as possible. Means, what is balancing of sight? For example, you have multiple points, right, profile leveling you are doing, so you have multiple intermediate points. So you kept the instrument at the center initially. So next time also you try to keep the instrument at the center, not towards the side. So always you keep the balancing of recording. So that is the balancing of sighting is there, right? If this side, if you are looking maybe 30 meter, then front side also try to look 30 meter or 35 meter, not more than the average value. For example, this side you have taken 30 meter, whereas this side you have taken 10 meter. So again, this is not balanced. So try to make as much as balanced reading, because this will reduce the errors. So, this is sight reflection of light and all will be reduced in that case. So the reading and the recording of observation correctly. Okay, so this is what we have done, and these are the errors and how we can basically take the precautions while taking the measure. So now the last point one I want to discuss in this slide is basically error propagation in labeling. So errors are basically propagated. So once you make errors, so some error will be simply propagated in each reading, and it may be sometimes the errors may be increasing cumulative error. Sometimes it is compensative errors. So the error propagation in labeling line varies as the square root of the number of instruments set up. So how many times you have set up the instrument, because whenever you set up the instrument, there will be temporary adjustment, permanent adjustment, this will be there. So as many as possible, we have to reduce the setup for the instruments. So less setup means less error will be occurring, isn't it? That's why the error will be root square of number of instrument or the root square of distance level. So the total maybe 30 meter or maybe 3 kilometer, 4 kilometer varying. So if you take the measurement for the smaller length, so error will be also less. This is also the square root of the distance level, and the third one is the square root of the length of the site. So that we are doing. So that's how basically with these three parameters the errors will be propagated, and our main objective will be try to mitigate those errors. So in this lecture, basically what we have understood is how the errors are introduced into our leveling measurements, and also what are the mistakes we do while taking the level and labels, and then lastly we have seen what are the precautions we have to take while doing the surveying. So in this unit, basically this is the last lecture in this unit 4, where we have understood how to take the vertical readings in the sense to find it out the profile of a terrain, or maybe a cross-sectional profile of a terrain, using the dumpy level or using the auto level, how exactly we can do the leveling. So this concludes this unit. Thank you.